Hello everyone, welcome back to LMJ, and today I am back with another video on the PYQs of NSEC, the qualifying Olympiad for chemistry, and we'll be covering the chapter periodic properties. We roughly have 25 years of questions, and this will be a speed solution video. So let us begin. So the first question says that the element whose electronic configuration is 1s2, 2s2, 2p6, 3s2 is a dash. So this is a very small electronic configuration, so you can find out which element it belongs to, and you can then accordingly choose the correct option. But if this electronic configuration would have been large, then you can use the Aufbau principle to look at the last electron, which is the differentiating electron being filled in the orbital. So that we can see using the Aufbau principle. The highest energy orbital in which the electron will enter is depicted according to the n plus L rule. So the L value for S, P, D is 0, 1, 2 and so on. So this would have 3 plus 0, 3, and this would have 2 plus 1, 3, 2 plus 0, 2. So these two have the same n plus L value. So in such case, we look at the higher n value. So this has higher n, 3 than 2. So 3s2 is the differentiating orbital, and we know that S block only contains metals, so option A would be correct. Moving on to question 2, it is asking for in which compound oxygen will show +2 oxidation state. So oxygen can show many different kinds of oxidation state. It is given in the table below. So most common is -2, which is shown in these compounds, the common compounds. -1 is shown in peroxides found by S block elements, and superoxides also found by S block elements. Na forms both superoxide and peroxides, and this is given in the NCERT. It can show 0 when it is bonding with itself, so O2 and O3 will have 0, and +1 is shown in, so positive oxidation state will be shown when it is coordinated with fluorine, because fluorine is more electronegative than oxygen, so it will pull electrons towards it, leaving a positive oxidation state on oxygen. So O2F2 has +1 and OF2 has +2. Some coordination compounds also show +1, so +2 will be shown in F2O. So oxidation state of Cr in K2Cr2O7 is, so this compound, the structure for this compound is given in D block chemistry in NCERT. So let us see. This will be contributing +2, this will be +1, this will be +2, and this will be +1. So this will lead to a +6 oxidation state. So answer is +6. Since this does not have any peroxide or superoxide bond, then we can use the mathematical formula also. So K will have +1, so 2 times +1 plus the oxidation of Cr we need to find, so we will take it as X. O has -2 since there is no peroxide or superoxide, so -7 into 2. This should sum up to 0 because the compound is neutral. So this will lead to X is equal to +6. Moving on to question number 4, it is asking which of these species will have the smallest size. So let us first see if they are isoelectronic species, because in such questions the species are usually isoelectronic, and in such case the one with the most protons is the smallest. So N3 minus has 7 plus 3 10 electrons. F minus would have 9 plus 1 10 electrons, and similarly O2 minus and Na plus would also have 10 electrons. So now we need to count the number of protons because they are isoelectronic species. So only the atomic number is contributing to the number of protons, right? The charge is contributing only to electrons. So this would have 7 protons, this would have 9 protons, this would have 8 protons, and this would have 11 protons. So Na plus has the most number of protons, so this will be the smallest species. This rule is very important. Roughly 9-10 questions have been asked in NECC from this rule only. So moving on to question number 5, it is asking for oxidation number of Mn in MnO4 minus. Like the third question, this structure is also given in the NCERT D block chemistry. So let us see. This will be contributing plus 2. This will be contributing plus 2. This will be contributing plus 2. This will be contributing plus 1. So the answer should be 7, right? Plus 7. Since this does not have any peroxide or superoxide, we can also calculate using the mathematical formula. So X, which is the oxidation state of Mn, minus 4 times 2, because the common oxidation state is minus 2 for oxygen, and this would be equal to minus 1 since this has a minus 1 charge. So X would be equal to plus 7. So question number 6 is asking, from the electronic configuration given of the given element K, L, M and N, which one has the highest ionization potential? Okay, so there is a misprint here. This should be equal to 2. So yes, 2. So now we solve the question. So the funda used in this question is that half-filled subshells are extra stable because they have the highest exchange energy. So half-filled subshells are very stable. So they will need extra energy to remove an electron because you are going from half-filled to not half-filled. So the stability is decreasing. So you need to supply more energy. So this will have a higher ionization potential. So since B has half-filled p orbital, so the answer would be B. And although D also has the half-filled p subshell, but we know that on going down the group, ionization potential decreases. So although both B and D have half-filled subshells, B would have higher ionization potential because it is higher in the group, right? Ne is higher than Ar. This is because of shielding effect. Ar will have more shielding effect, so this P will be less tightly bounded to the nucleus, so it will be easier to remove the electron from half-filled subshell than in Ne. So moving on to question 7, it is asking, the formation of anion from a neutral atom X is favored by. Okay, so formation of anion means adding the electron. So if the neutral atom would have high electron affinity, so on adding the electron, more energy will be released and it will form a stable compound. So option A should be correct. Let us see the other options also. Large size of X is not favorable because the incoming electrons are further from the nucleus, so there is not much electrostatic attraction and it is shielded by the core electrons, so there is weaker attraction and anion formation is less favorable. Always remember that attractive force is favorable because it releases energy and forms stable compounds. So low ionization potential means that it is easy to remove the electron rather than adding the electron. So it is easier to form cations. So anion formation would not be supported. C option is also wrong. D is saying high charge on anion X. So if it has high charge, so while forming, although X minus would be favorable, but X2 minus or X3 minus would require overcoming the repulsion, because if there is already a minus charge, it would repel the electron. So repulsive force is not favorable. So it is also not favorable. So answer is A. So question 8 is a very good question. Although this electronic configuration part is from the F block chapter, it is also a part of periodic property. So we are seeing it here. So the outermost electronic configuration of one of the element is 5f2, 6d1, 7s2. So this element will belong to. So earlier we saw the Aufbau rule that higher n plus l value will tell us the valence orbital, right? But here f has the l value of 3, so this would have 8, and this will also have 8, and since 6 is greater than 5, so higher n is in 6d, so this should have been the valence shell. But this is not the case here, because you can see that the 6d1 is being filled before the f thing is filled completely, right? 6d1 should fill after f is completely filled. That is, it has 14 electrons, but 6d1 is being filled before f5f2 is completely filled. So this is an exception. You can see that the 91st and 92nd electron, 91st and 92nd element are exceptions to the Aufbau principle, because 6d1 is being filled before 5f is completely filled, and from plutonium and americium this exception gets fixed. So this is because in the Aufbau principle is only a fantastic guide for small elements. For heavy elements where many orbitals have very similar energy, so 6d and 5f have very similar energy, so they are filled in random order. So the ground state configuration is a delicate balance between orbital energy, minimizing electron-electron repulsions and maximizing the exchange energy. This 5f2 6d1 7s2 is not a d block element or transition series. The 5f elements belong to the actinide series. So this would be more clear when you read F block chapters from NCERT. So question 9 says, which element of the third row has biggest atomic size? So this question is actually wrong, because neon is in the second row and it is not in the third row. So this is a wrong question. Although the answer was given D, because the question is based on the fact that in a row, the largest atomic size is of the noble gas, because noble gases don't form any bonds with other elements. So for noble gases, we don't take the covalent radius as we take for the other elements. For noble gases, we take van der Waals radius, and van der Waals radius is always greater than covalent radius. So if this would have been argon, which is in the third row, option D would have been correct. Moving on to question 10. Which oxyacid of chlorine shows oxidation state of +5? So this is again a question from P block, but it is given in periodic properties because we generally remember these chlorous acids or chloric acids. So if you know the structure on the naming convention, then you know that hypochlorous has +1, then we have chlorous, then we have chloric, then we have perchloric, and the oxidation state has a difference of 2 between them. So +1 and +3 have difference of 2, then +5, then +7. So +5 is in chloric acid. You can also see from the structure that this oxygen will contribute +2, this will +2, and this will be +1, so +5. So chloric acid is correct. You can remember the acids in the order of their increasing oxidation number. So hypochlorous, then chlorous, then chloric, then perchloric. Question 11 says that which element does not show positive oxidation state? So the correct answer would be fluorine, since it is the most electronegative element in the periodic table. So it will always attract electrons towards itself, and it cannot show positive oxidation state because no other element can snatch the electrons from fluorine. So it will always have negative oxidation state. Question 12 says that due to addition of electrons in d orbitals for transition elements, the screening effect. So the screening effect is the effect where the inner shell electrons reduce the amount of positive nuclear charge felt by the outer shell electrons. So if this is the nucleus and there are already electrons, so the electrons in the outermost shell will face less attraction from the nucleus because these electrons are obstructing the attractive forces. So if we add electrons, then obviously the shielding effect would increase. Although the shielding effect of d electrons is less because of their shape, but still it increases. So this question is important because it has been asked 2-3 times in NSEC. So moving on to question 13. This is a nice question. The diagonal relationship of elements in the periodic table arises because of similarity in. So the correct answer would be the charge by radius ratio, because the charge by radius ratio is also known as the ionic potential, and it is a simple but powerful concept used to predict the bonding behavior. So the chemical properties is depicted by the charge by radius ratio. So it tells us about the polarizing power of the cation. It is the ability of positive ion to attract the electron cloud, because if the positive charge is stored in a very small radius, then it would be very positively dense element, right? And the charge by radius ratio would be large because radius would be small, so it would be more polarizing than a positive charge which is spread among a largest radius. So let us see an example. So BE has +2 charge and the radius is approximately 45, and although Al3 plus has a higher charge, the radius is also larger, so the ratio would approximately be same. So their polarizing power is almost same, and they can form bonds with similar degrees and show similar chemical properties. So the correct answer for diagonal relationship is the charge by radius ratio. Question 14 says the atom of element X contains 27 electrons. So X is expected to be, okay, so it has 27 electrons. So after argon, there would be 2 electrons in the s orbital, and then in 3D, there would be 7 electrons, right? So because argon is the 18th element, after that we add 2 elements to make it 20, and after that we add 7 elements in 3D to make it 27. So the electronic configuration would be something like this, that first single electrons would fill in each box, then double electrons. So since this has 3 unpaired electrons, and the atom which has unpaired electrons is known as paramagnetic, so it would be a paramagnetic element belonging to the D block. So question 15 is based on the Mendeleev periodic table, and even if you don't know the Mendeleev periodic table, this is a nice diagram to remember the Mendeleev periodic table in relation to the modern periodic table. So this has 2 types of groups, one which has the A and one which has B. So the A are the S and P blocks, so 1A, 2A, 3A, 4A, 5A, 6A, 7A and 8A, and this is also sometimes known as the group 0. And the transition elements have the B subscript, so U and Zn have 1B and 2B, and then we go back to the beginning of the D block, 3B, 4B, 5B, 6B, 7B, and the 8 group has 8 group has 3 elements in one period, right? So in the period 4, group 8 has 3 elements, Fe, Co and Ni. So this is also an important concept because question has been asked on this concept also. So the group in the periodic table that contains all the elements in different physical states. So in all the different physical states, so that is gas, liquid and solid. So only this group 7A, which is the noble gas group, has the elements in all different kinds of physical states. This is a fact because it has gaseous elements like fluorine and chlorine, liquid elements like bromine. So there are only 2 liquid elements at room temperature in the periodic table, that is mercury and bromine, and solid elements iodine and astatine. Although astatine is a radioactive element, it is predicted to be solid. So the option is 7A. 5A all contains gases and solids, but it has no liquids. 1A, which is the S block, it has gases and solids, but it has no liquids. And 4A has carbon and leads, which are all solids, so it has only solids. So the only correct option is C, which is 7A. 16 question is a very good question. It is asking the ion having a noble gas configuration is. Okay, so the true noble gas configuration means that if an element is in the nth row, the outer configuration should be ns2 np6. So Fe3 plus has 3d5. So since Fe is in the fourth row, it should have 4s2 and 4p6. Although it has 4s2, but it does not have 4p6, so B option is wrong. Cr3 plus also does not have 4p6, so it is wrong. Some people might say that Cu plus has a noble gas configuration, but it is wrong. It has pseudo noble gas configuration because it also does not have 4p6. So option D is also wrong. Many people got confused here. So the correct option is the remaining option, Se2 minus. You might not be knowing the configuration of Se, but by eliminating the other 3 options, you can mark option A. So Se has Se2 minus would have 36 electrons, and it has 4s2 and 4p6. And since it is in the fourth row and it has 4p2, 4s2 and 4p6, it has noble gas configuration. So this was a nice question. Moving on to question 17. So the element with Z is equal to 83 belongs to which block? So for solving this question, you must remember the magic numbers. So 2, 8, 8, 18, 18 and 32. So this is the number of elements in the first row. This is the number of elements in second row, third row, fourth row, fifth row, sixth row. So the total elements till second row would be the summation of the elements in first row and second row, right? So till second row, there are 10 elements. Till third row, there are 18 elements. Till fourth row, there are 18 plus 18, which is 36 elements. Till fourth row. And there would be 36 plus 18, which is 54 elements till fifth row. And there would be 54 plus 32 elements, which is equal to 86 elements till the sixth row. So since Z is equal to 83, so this would be really close to the end of the sixth row, right? So we can directly say that this would belong to P, because P is to the end of the sixth of every row. The end is the P block. So we can also see using the number of elements in each block. In each block. So till fifth row there are 54 elements. So after 54, there would be 2 elements in the S block. There would be 14 elements in the F block. There would be 10 elements in the D block. And 83 minus 54 is equal to, this is equal to 29 electrons. And we have used 26 electrons, so there would be 3 electrons. So it would belong to P orbital, right? So it belongs to P block. So the answer is B. This was a nice question. You must remember the magic number. So moving on to question 18. Which of the following has the highest electron affinity? So this is also a nice question. Electron affinity is the energy released when an electron is added to a neutral atom in the gaseous state. So this is the definition of electron affinity. And the general trend is that it increases across the period and it decreases down the group, because due to shielding effect, the nuclear attraction felt by the electron that is getting added is less, so EA would decrease, and across the period the nuclear the Z effective or the nuclear attraction increases, so there would be greater attraction for the electron that is getting added, so more stable compound would be formed, so EA increases, which means that it becomes more negative, right? So you might think that since they belong to the same group, so the one at the top, which is fluorine, must have the highest electron affinity, because we know that it decreases down the group. So I must have the least and F must have the most negative EA. But there is an exception. So we might think that F should have the highest electron affinity, but fluorine has the highest electron affinity, because in fluorine the size is very small. So there is repulsions between the 2p electrons that it has. So the electron that is getting added will also face repulsion. So the stability is decreased. But in chlorine, the 3p orbital is bigger. So there is more space to accommodate the electron that is getting added. So there would be less repulsion. And the compound would be more stable. And higher energy will be released. So it will have more negative electron affinity. So the correct option is option C. So the element having electronegativity next to fluorine is oxygen. This is a very factual question. Question 20 is again based on the Mendeleev's periodic table. So the group in the long form of periodic table having 3 elements together is. So we already discussed that the 8 group has 3 elements together. right? Because the fourth period would have S, E, C, O, and Ni. Fifth row would also have three elements together in the 8th group. So the answer is D. 21st question says that atom with the largest electron affinity is. So we already discussed that chlorine has more electron affinity than fluorine, and it is also the element with the largest negative electron affinity, because we know that the electron affinity decreases down the group. So the element having the most electron affinity should be at the top of the periodic table, and also it should be at the right side of the periodic table because it increases across the period when we move towards the right. So it should have been fluorine, but it is chlorine because of the exception that we already discussed. So this was the first part of the speed solutions of the chapter periodic properties for the exam NSEC. So let me know how was this video, and if you have any suggestions for the next part. The next part will be releasing very soon, and you can ask your doubts in the Telegram group or the comment section. And also, if you have any suggestions for what I should upload next, you can give them to me in the comment section. So bye everyone. Don't forget to like and subscribe.